We will now use the basis to represent a vector x in V as a coordinate. So what do we mean by that? Let x be the vector of interest. X belongs to V, and we have B1 to Bn as the basis that spans V, and we can put this as B1, B2, and Bn. And remember that since this is a basis, they must be independent set. And we can find a vector C1, C2, and Cn such that we will perform a linear combinations of B. And since B, the basis vectors, are independent, therefore the coordinate scalars C1 to Cn is unique. To prove, what we do is that we assume that x can be represented by another coordinate vectors d1 to dn, and d1 to dn here is assumed not to be the same as c1 to cn. And what we then do is x representing using the d coordinates and the c coordinates may be different, but we will prove that they are the same by doing this. X minus x, x represented using the c coordinate, x representing using the d coordinate. So basically we will get this equality. And remember that since b's are independent, then to get the zero vector, this must be 0, implying that C1 equals to D1. And that is the proof. We can look at it another way. If we have x belonging to Rn, then we can cast the basis as a matrix. We call it PB. And this PB is an n by n matrix, since first, each of these B1 to Bn must be Rn. And since there are n of them, to be a complete or to be a basis to cover the space, to span the space, so PB is an n by n matrix. Each column of PB is one of the independent vectors of the basis B. Now, because each of the column B1, B2 to Bn is independent, therefore PB is invertible. So what we now can do is to cast this expression x equals to PB, because this is what we are trying to do. X equals to PB multiplied by the C vector. Okay. Now, since PB is square and invertible, PB minus 1 exists, and therefore what we can do now is we multiply both sides by PB minus 1. This is PB minus 1 times PB. We're getting rid of this because this is identity, showing that the coordinate vector C is PB minus 1 times x. Since PB minus 1 exists, C is unique because this is nothing but a matrix multiplying by a vector, and a unique representation will come out of this because PB minus 1 is in